Water is essential to life on Earth. In its three phases, solid, liquid, and gas, water ties together the major parts of the Earth's climate system: air, clouds, the ocean, lakes, vegetation, snowpack, and glaciers. The water cycle shows the continuous movement of water within the Earth and atmosphere. It is a complex system that includes many different processes. Liquid water evaporates into water vapor, condenses to form clouds, and precipitates back to Earth in the form of rain and snow. Water in different phases moves through the atmosphere, transportation. Liquid water flows across land, runoff, into the ground, infiltration and percolation, and through the ground, groundwater. Groundwater moves into plants, plant uptake, and evaporates from plants into the atmosphere, transpiration. Solid ice and snow can turn directly into gas, sublimation. The opposite can also take place when water vapor becomes solid. Evaporation is the process by which water changes from a liquid to a gas or vapor. Evaporation is the primary pathway that water moves from the liquid state back into the water cycle as atmospheric water vapor. Studies have shown that the oceans, seas, lakes, and rivers provide nearly 90% of the moisture in the atmosphere via evaporation, with the remaining 10% being contributed by plant transpiration. A very small amount of water vapor enters the atmosphere through sublimation, the process by which water changes from a solid, ice or snow, to a gas, bypassing the liquid phase. This often happens in the Rocky Mountains as dry and warm Chinook winds blow in from the Pacific in late winter and early spring. When a Chinook takes effect, local temperatures rise dramatically in a matter of hours. When the dry air hits the snow, it changes the snow directly into water vapor, bypassing the liquid phase. Sublimation is a common way for snow to disappear quickly in arid climates. Why evaporation occurs? Heat, energy, is necessary for evaporation to occur. Energy is used to break the bonds that hold water molecules together, which is why water easily evaporates at the boiling point, 212 degrees Fahrenheit, 100 degrees Celsius, but evaporates much more slowly at the freezing point. Condensation is the process by which water vapor in the air is changed into liquid water. Condensation is crucial to the water cycle because it is responsible for the formation of clouds. These clouds may produce precipitation, which is the primary route for water to return to the Earth's surface within the water cycle. Condensation is the opposite of evaporation. You don't have to look at something as far away as a cloud to notice condensation, though. Condensation is responsible for ground-level fog, for your glasses fogging up when you go from a cold room to the outdoors on a hot, humid day, for the water that drips off the outside of your glass of iced tea, and for the water on the inside of the windows in your home on a cold day. The phase change that accompanies water as it moves between its vapor, liquid, and solid form is exhibited in the arrangement of water molecules. Water molecules in the vapor form are arranged more randomly than in liquid water. As condensation occurs and liquid water forms from the vapor, the water molecules become more organized, and heat is released into the atmosphere as a result. Precipitation is water released from clouds in the form of rain, snow, or hail. It is the primary connection in the water cycle that provides for the delivery of atmospheric water to the Earth. Most precipitation falls as rain. The clouds floating overhead contain water vapor and cloud droplets, which are small drops of condensed water. These droplets are way too small to fall as precipitation, but they are large enough to form visible clouds. Water is continually evaporating and condensing in the sky. If you look closely at a cloud, you can see some parts disappearing, evaporating, while other parts are growing, condensation. Most of the condensed water in clouds does not fall as precipitation, because their fall speed is not large enough to overcome updrafts which support the clouds. For precipitation to happen, first tiny water droplets must condense on even tinier dust, salt, or smoke particles, which act as a nucleus. Water droplets may grow as a result of additional condensation of water vapor when the particles collide. If enough collisions occur to produce a droplet with a fall velocity, which exceeds the cloud updraft speed, then it will fall out of the cloud as precipitation. This is not a trivial task since millions of cloud droplets are required to produce a single raindrop. A more efficient mechanism, known as the Bergeron-Fine-Diasson process, for producing a precipitation-sized drop is through a process which leads to the rapid growth of ice crystals at the expense of the water vapor present in a cloud. These crystals may fall as snow or melt and fall as rain. Please like, subscribe and ring the notification bell for more great videos like these. Thank you for watching.